Hello, and welcome to my prediction for the 2018 exam season for science for the new grade 1 to 9 exams. Maybe slightly skewed towards a physics focus here on this video. So, when we say a prediction, what do I mean by that? I'm saying that we can look ahead and we can look to see what AQA has published from their specification for this new exam, and we can predict what certain things are going to come up. And I can say, how can you predict that? What can you know? Well, because we've been told what some things will be. We know for sure what some things will be, and we'll talk about what we mean by that. What we can't do is predict, what each question will be on and what part of the topic will it be on. There's just no way of doing that. But there are some things we can predict, and then there's some things that we can speculate over, that we can try and predict about. So that disclosure on that later part of the video is just literally conjecture. It's just what I think, my opinion of what I think we should maybe focus on, in those few nights just before the exam. You've obviously done your full revision. You've revised absolutely everything you can in the physics syllabus. But maybe that few little things that you think, oh right, I'm gonna look over that in this few nights before the exam. So first things first, what do we know? What has AQA told us that this exam will be on? And the first thing that we know for sure is the math skills in science. So what have we been told? What have we been told by AQA? So if I was you, if you're not already familiar with going on to the AQA website, I would try this out. Come and use the website. Get used to your way around there. And you've got on here, so we want to be careful as we're not going on 20 exams from 2014. That's from the old spec. We're looking from the new spec here, teaching from 2016, and then you guys, unluckily for you, is unfortunately you are the first ones to do this new exam. So why do some people see that as a disadvantage? Because we haven't got lots of past papers of this from this syllabus to have a look at what the things could be. We absolutely should be revising. We should be doing the old exam papers because they will still be useful. But we've only got the few specimen papers to look at for you guys for this 2018 exam. So what should we be going on? Should we go on combined science or maybe physics or chemistry, biology if you're doing the triple course? If you're doing the double, you're either if you in certain schools you've done synergy. Most schools went with the trilogy, which means you were still probably taught physics, chemistry, and biology separately in different units. Synergy is when you might have done these as a bit of a mix together. So if you go onto the combined science or the physics, whatever it is, and you look at assessment resources, what can we look at on here? So this is all absolutely available for anyone to look at. I'm not logged in on my account, so anyone can come look at this stuff here. There's some things on this site which are locked, which teachers or people in the school would have access to, and pupils would not. But I'm not logged in here, so that you guys can absolutely come and have a look at this. So if we look on our exam guidance, so I'm going to download that PDF. I'm going to have a look at that. So if we look on our exams explained, what do we mean by this math stuff that's going to come in? If we look at page 8, so look at, and we're going to look at what do we know will come up. Well, they've told us here it's in writing in AQA's own report that a minimum 10% will be in biology, 20% in chemistry, 30% in physics. 30% in physics, absolutely massive, absolutely massive. So when you consider that for the new, I think if some of you are probably aware of how low some of the grade boundaries were last year for the new maths course, the new 9-to-1 maths course, with some of the level 8s and 9s only 50, and I think it was 58% or something for a level 9. It was extremely low. So imagine what we can't know for sure yet what the grade boundary would be for the new GCSE sciences, but what that is a massive amount to go towards. Let's say it was just 58, 60, 65% for a level 9. 30% of the exam is going to be math skills. So for combined science, it's a minimum of 20% across the three. So what do we mean by those math skills? So absolutely one of the core things that you should be doing for your GCSE physics exams is you should be revising on absolutely 100% memorized by now the physics equations. So if you haven't got those are available on the physics specification. So either going to combined science, want to go on the physics spec. and then if you download the specification here, specification for teaching of 2016, so I've got it open up here. Let's look at the physics one, and I think this would be right at the bottom. Yeah, in the appendix there, we have got our physics equations. So there are a lot there. There are a lot there. How many? 23. 23 that you have to memorize. So in previous years, you would be given these equations. You would have equation sheets with your exam, and you could just, oh, I'm going to do a question on acceleration. Oh, what is it? Oh, change in velocity over time. Nice and easy, almost guaranteed marks, okay? Whereas now you have to memorize these. So, but it's worth, it could up 30%, minimum 30% of your exam. We know that's going to be in your physics exam. If you have not learned these, you are absolutely crazy. Absolutely crazy. You are throwing marks away. So what you do get given is some of the harder equations they will provide for you to use. So remember now, if you are someone who is in a sitting higher tier, sitting higher tier paper, you would not just have to memorize these equations. It's very unlikely in a higher tier paper that you would just be given what is power, power or energy transport over time, and put that in. Oh yeah, 2, 3 minutes. No, that's not going to happen. What you're much more likely to have is kinetic energy, or what is the speed from the kinetic energy? Maybe you've only been given the mass, and then you'd have to rearrange it to work out the speed. And also, what else could they do? Maybe they've given you mass in grams. Maybe they've given you time in minutes, and you have to convert it to seconds. Maybe a big one to watch out is things like in current. They often give in higher tier papers in milliamps. So remember, you've got to then divide by 1,000. There's 1,000 milliamps in an amp. So look out for things like that. So 30% of this for the physics. What about then the chemistry? So for the chemistry, you're going to be looking for things like the reacting masses, the number of moles, the number of, just look up here, reacting masses. Oh, I'm sure it is still on the double spec for combined science. Yes. Is it? Is it? I'm sure it is. Sure it is. You have to have the reacting masses, things like that, on the double spec, as well as obviously then you've got the quantitative. That's what I'm looking for. The quantitative chemistry. The quantitative chemistry topic. There it is. So yeah, the quantitative chemistry topic, you've got conservation of mass, your amount of masses, and then using the moles, mass over molecular mass. All that stuff is going to go towards the 20%. If you're doing triple, there's a few more things. There's like the yields and things like that, concentrations, things like that. I think RF value is in both for the chromatography. For biology, it would, that 10% is going to be things like the magnification, little equation on magnification. But be aware, for all three sciences, it might not be any of your physics equations, things that are equations that you have to remember. Maybe it could simply be things like working out a mean or working out a percentage or something like that. So that's something we know is going to come up. We know there's going to be maths questions in our science exams. What's the next thing that we know for sure is going to come up in some way? And that is this new thing, the working scientifically, the new working scientifically part of the course, which is all about the required practical. So on previous years, there was the control assessments or the ISA or the what used to be coursework. That has all been removed for you guys in this year. So you were the first people to not have that 25% or whatever it was in previous years. That was practical work. So they have to assess that in a different way, and that's where this required practical, the working scientifically things. So the required practicals were the ones that you should have been completing over your 2 years studying the GCSE. So again, if you want to look at what they were, your teacher's probably giving you a handout. But if you go onto the AQA website, you can go on to the teaching resources. So if you go on to the subjects like combined science, and you can actually go on teaching resources, and you could go on practicals there, and you can look at these required practical handbooks. Again, you do not need to log in. You guys can access this. So if we look at the physics one, we can see there's the required practical handbook for physics. So there's more, I think there's more experiments that require practicals for the physics course, more so than the chemistry and the biology. So obviously for the triple people, you guys will have to do a few extra, well, it's also outlined nicely here. You guys will have to do a few extra experiments for your biology, chemistry, and physics. There's a big list of them here. So we know if we look at the that exam, our exam sheet again. So this is that document, our exams explained document. And if we look at working scientifically, 7. So, blah 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 blah. Right. Where is the percentage? Working scientifically is a fundamental part of learning science. Students need to work their scientific skills. And it talks about the extended response here. And I think the working scientifically part comes up to about, that's it, 15%. So 15%, we know, minimum of 15% in all three sciences is going to be towards the practical stuff. So that means looking at the required practical activities, those experiments. So make sure you are revising those experiments. You can describe them, you can explain them, but you also can talk about things like, oh, how would you improve them if there was any safety issues with them. But it's not just the required practicals. Do not go into this thinking you could just memorize those required practicals, which would be a lot of work. You need to do it, but there's a lot of work. There's a lot of required practicals there. But it could be other stuff as well. It could be things like talking about accuracy, precision, reliability. It could be things like talking about uncertainty. Or it does state here that some questions will be on theoretical aspects of experimentation, or for non-required required practical context. So then what they're saying here is that means that maybe it's an experiment that you've never seen before. It's not one of the required practicals. You would still be able to apply your skills to that experiment. All relevant information will be given in the question. So it's not as if they're going to throw some random experiment at you and ask you to, describe a method or something like that. They're going to give you some information, and you would have to, I don't know, write a conclusion on it, maybe analyze it in some way. If you're lucky, plot a graph and work out some information from it. Because I think that'll be some nice, easy marks. So we can see that if we look on the specimen papers, so if we look, this is one of the specimen papers again. You can download this off the AQA website. So if you go on Combined Science, again, I've got the specimen papers here, or on the GCSE physics one. And this was one of the first specimen papers. There's 2 sets that are out. Your teachers probably gave you them for your mock exams. So if we go to, what was that one on? It was on statues. So this is a nice one here. So 6 marks. And actually, it's the type of one where if you know how to do it, you revise your required practicals. This was one of the required practicals looking at densities of uniform and non-uniform objects. So like, for the small statue to put in the water, the displacement can, gets volume, gets mass, and then obviously just working out the volume for the metal cube. This was the type of one where it would be nice, easy marks if you know it. But that said, if you actually look at I'm not going to go into it all now, but if you look at the mark schemes, you actually have to be very specific when you're describing your methods for these required practicals. When it's things like saying for the mass, you're talking about, I would use to measure the mass, I would use a mass balance. You can't just say, I'd work out the density. You need to say, I work out the density by doing mass over volume. Well, how do you get the volume? Well, I need to measure each side with a ruler and then do length times width. So they're very, very fussy in the way that they want you to explain these questions. They could ask you again. Let's just look at another. They could ask you for other things. So let's have a look. So this is another one now. So this is another required practicals. So this is the specific heat capacity one. Again, so how many marks it is? 3 marks for drawing the diagram, and 6 marks then describing how you would use it and then how you would work out. So, so this is one of the ones that, if you haven't revised it properly, you're getting absolutely hammered. Absolutely hammered. That's 9 marks gone. Whereas if you revise it properly, it's a good that you're going to pick up high marks on this exam question. So this is on the paper. Oh, this is from set 2. So this is from the set 2 papers. So I don't think that you guys have access to that, but they should be provided online before your exam. So these what be, schools would have access to these set 2 specimen papers to give mocks to their pupils before the summer exam season really kicks off. Right. Let's get to the bit now, the controversial bit. How can we predict things? Because those things so far, math skills and science, working scientifically, we know they're going to happen. We've just seen that. We know there's going to be some questions on them. But what's the conjecture bit? What's the bit where I'm pulling something out of the bag and I'm saying I think that this happens? And that is the changes to the course. So I've got a bit of a disclosure there, a bit of a warning. Careful of this bit. I'm not saying to ignore the rest of the course. Absolutely not. You obviously have to revise everything properly. This is not one of those things where we're going back and looking at what the 6 markers have been in previous years. I think that's a waste of time with this new course, especially the way they started doing the 6 markers in previous years. Where, it was literally a 6 marker on anything. There wasn't certain questions they were doing 6 markers on. It was literally on anything. So what do I mean by change to the course? And what am I saying then? Oh, if I'm still revising everything, what do I mean? I'm saying that you concentrate a little bit of the extra work on the things that they've changed. Things that they've changed. So what I mean by that is what they've changed compared to the GCSE in previous years. So from these old 2014 courses, what have they changed? Because I know from teaching the A level, so the A level physics changed in 2015, and they changed a few things that were in the course. And on that first exam in 2015, 2016, there was a good few questions on the things that they've put into the course. If you think that if you're an examiner, the first thing you do as the chief examiner, if you have teachers go on training days with chief examiner, and they say that the first thing they do is they get the specification up in front of them, and they go, all right, so we're going to do a question on that, we're going to do a question on that. If you're an exam board and you've changed the specification to put some new stuff in, I just think that it's almost not, I wouldn't say sure thing, but it seems very likely that there's going to be stuff there that they've put new into the course from the new syllabus, that was prescribed that was then prescribed to them. They're going to examine on it. Okay, so what are the changes to the course? So if you wanted to look at the physics one, for example, we go on GCSE physics, as we now see, and then we look on planning, I think it was under planning resources. So this is some information that's provided to teachers to help them when this first course come out. And you can go on summary of changes. Okay. Now, if we go on the summary changes, you can look at the combined science one. You can look at the chemistry and biology ones. We can look at what was in there before, and now what's changed, what's new into the course, and there's some quite big changes. Okay, quite big changes. The number one thing that I would say to look at and to concentrate on, that actually caused a little bit of controversy when it came out between teachers, because it actually went back to like they used to do it in the olden days, even before my time, and that was the way that energy is taught. So this energy stores and systems, they brought in all that stuff on pathways, about pathways between energy. That was all new. So about the mechanical pathway, electrical pathway, heating. I think that's going to come up in some form or another. Make sure that's one of the things you want to be looking over that night before your exam, because I think that's the thing to do this. I'm not saying just ignore everything else. I'm saying that to put that little bit of extra work into some of these things that they've changed, because I just think that it's good. If I'm putting money on anything, that's one of the things I think is going to come up. So we go look back. We're not going to go through them all because there's quite a few. I just have a quick look through this document if I was you. Scalar and vectors are always somewhere in there, but the way that they've done it. So there's this extra information, this stuff on components. That was the stuff that some people are actually struggling with, because that's been brought down from AS physics. And that's like resolving a vector into its components and then using scale vector diagrams. So that's when you're finding a resultant vector using that parallelogram stuff. Have a look over that. If you don't get it, that's the type of stuff that's going to be 3 or 4 marks if you get a question up on that. It is higher tier only. What else? What else? The other big thing is this whole new topic on pressure. So this is physics only. So don't panic if you're in combined science and you don't have a clue what I'm talking about. There was some pressure stuff in the combined science, but this is the pressure and fluid stuff. And again, this is all new stuff, and somewhat difficult. Somewhat difficult. So I would be looking over that. Other stuff that's new is other big change was the electromagnetic stuff. So not electromagnetic waves. That's always been there. Electromagnetism. That's what I'm looking for. So the stuff on motors have always been in there. But some of the stuff's changed. So this F equals Bill, that is that's an A level, actually not even an AS. That's an A level equation that's been brought down. Whereas there's other stuff on like the uses of this stuff, loudspeakers. That's what I'm looking for. Loudspeakers is all new. Things like using the microphones is new. I'd really be spending a little bit of time looking through that night before your exam. There's a few extra little things. There's stuff like on satellites, which is new. Space stuff was always there. Redshift was always there. Yeah, so microphones there. Particles, some of this new stuff that is in the combined science stuff. Other stuff that I think is new. Specific heat capacity's always been there, but the stuff on latent heat and bringing them to get together, that's new. So it's definitely worth your time. Have a look through this document. Have a look through it. Have a look through chemistry, biology, and the physics. Our specifications. This is the changes that Ofqual made, and then AQA had to implement. So would have EdXL. They can take their own sort of spin on it, but they still have to cover what Ofqual is saying from the DFE, Department of Education. What's the big change in one of the equations? Last thing was the where is it? The V squared. Oh yeah, the elastic energy equation is completely new. And then the V squared, this AS, the Suvat equation that's been brought down. Make sure you can rearrange and manipulate this equation, because I think that is one that will come up. That is one that's actually given to you, but make sure you can rearrange it. So that's it. That is my prediction for the 2018 exams, especially obviously concentrated more on physics, but so math skills, practical stuff, and then if you're looking for what could come up, maybe there's going to be a 6 mark on one of these things. Maybe it's going to just be some big 3 or 4 mark questions. Look at some of those changes. Can't say for 100% sure, but I will be really surprised if they don't at least have a few, or maybe slightly more biased, some more bias towards getting these changes and try and ask questions on them. If you're an examiner, it's quite difficult to think of different exam questions every year. You must notice you're doing the past papers. The exams get a little bit repetitive. So you're going to look to get something new in there. And I think it's going to be one of these changes, or some of this stuff with these changes. Okay, thank you. We'll analyze it. It'll be interesting to see after the first paper in a couple of weeks' time, have they got these changes in? And what we'll do is maybe then help us predict a little bit what is paper 2 going to be on after the half term.